So, good evening, everyone. On behalf of Confederation of Indian Industry, I welcome our distinguished speaker and all the participants. I sincerely hope each one of you is following the social distancing discipline and keeping safe and healthy. As we are all aware, COVID-19 is spreading rapidly around the world and is having a significant impact on businesses and the normal life. India is no exception, and with a long lockdown and resume of work, daily operation in faces, the challenges for the individuals, governments, and industries are only multiplying. The current pandemic has once again highlighted the important role played by technologies. The pandemic has accentuated the promise of emerging technologies and use of advanced analytics tools to help address some of the critical issues and make it more efficient, effective, and accessible. The application of machine learning has shown tremendous promise across a broad array of applications. However, most of the individuals and industries are not yet familiar with the concept of AI. While there is a realization that AI has considerable potential for altering business processes, but it is yet not clear how AI could be deployed for their sectors. Keeping this in view, the webinar on what is this thing called AI is being organized. The webinar will highlight on the potential AI holds for different domains, while also giving audience an opportunity to ask their queries. And to deliver the same, we have Professor Balaraman Ravindran, Department of Computer Science and Engineering, Head RBCD's SAI IIT Madras. Now, without taking further time, I request Ms. Aarti to kindly give us a brief introduction and start the webinar. I also request all the attendees to ask the questions through Q&A section, which will be addressed at the end of the session. And now I request Ms. Aarti to please take it over. Ms. Aarti.
Yeah, thank you. So good evening, everyone, and welcome to the webinar on what is this thing called AI. I'm Aarti, and I work as project manager for AI solutions for Gyan Data Private Limited. And I'm honored to introduce our esteemed speaker for today. Dr. B. Ravindran heads the Robert Bosch Center for Data Science and Artificial Intelligence at IIT Madras, the leading interdisciplinary AI research in India. He's the Mindtree Faculty Fellow and Professor in the Department and Engineering at IIT Madras. He received his PhD from the University of Massachusetts, Amherst, and his master's from the Indian Institute of Science, Bangalore. He has more than 2 decades of research experience in AI and specifically reinforcement learning. Currently, his research interest spans the area of reinforcement learning, complex networks, and geometric deep learning. He has held visiting positions at the Indian Institute of Science, Bangalore, and University of Technology, Sydney, and is currently a visiting researcher at Google. One of the founding executive committee members of the India chapter of ACM SIG KDD, and is serving as the president of the chapter. He has been recognized in 2020 as a senior member of the Association for Advancement of AI for his long-standing contributions to AI. He has published over 100 papers in journals and conferences, including premier venues such as ICML, PlayEye, HCI, ICLR, NUR IPS, and AAMAS. He is currently serving on the editorial boards of Journal of AI Research, PLOS One, and Frontiers in Big Data. His video lectures on NPTEL are widely viewed and have received accolades for their depth and delivery. He has been closely collaborating with various industrial research labs and also serves on the advisory boards of several startups. In fact, my introduction to the field of data science was Dr. Ravindran's field course on data analytics. So I thank Dr. Suchitra Geeta for giving me this opportunity to introduce him. So welcome, sir. We are so glad you could make time to educate the wider audience about AI. So without further ado, Professor Ravindran, the virtual floor is all yours.
So thank you, Aarti. Thank you for the generous introduction. And so I'm going to talk about. I mean, you can see from the title itself, right? This is not going to be a very technical introduction. So people don't know this is a callback to an old song that's titled "What is this thing called love?" Right? So I'm going to keep it light. At the same time, I'm going to try and make sure that people understand what at least are the primary issues that AI concerns itself with during the course of this talk. So before I go further, I just want to do a sanity check. Am I clearly audible?
Yes.
Yes, sir.
Yeah, great. Thank you. Yeah. Let's start off with this question, right? So what is AI, right? So people have differing views of AI ranging over the whole gamut, right? AI is like the Terminator come to destroy us, or AI is like, the panacea, the cure, heralded by angels that's come to solve all ills of the world, right? So what is the truth, right? The truth is somewhat very mundane. AI is a piece of software. If you take nothing else away from this talk, right? This is one thing that I want you to take away. AI is a piece of software. AI is not magic. AI is not evil. You can't attribute characteristic to a software. So it has all the problems that you have with badly written software. You have all the problems that you get. I mean, all the advantages that you get by a clever piece of automation that you can do. So if it's just a piece of software, so why should you care about AI? Why is that this hype, right? So it's AI is this collection of technology, right? That basically started pervading your life, right? So AI is everywhere. If you go to Google, right? And how many of us don't? I don't think that there's one person here in the audience who hasn't used Google search in the last day, maybe if not the last week, right? So Google uses a lot of AI in making sure that you get the right searches. And it's just not Google. Any search engine that you use is going to use that, right? Or you log into Facebook and we are so used to these faces popping up with names on top of them and or with question marks where you type in names and so on and so forth. But it's all coming from AI, right? And whenever you use Google Map or you place an order for your food or Amazon or Flipkart, anything, that is AI that's behind that, right? Whether it is for routing your food orders properly or making sure that you are getting the right recommendations, right? So whether it's the advertisements on your web page or whether it's talking to Amazon, Alexa, or Google Home. So AI is really everywhere, right? And not just these kind of slightly frivolous applications. AI has also been looking at making significant difference to how people are thinking about healthcare nowadays, right? Here are some examples of where AI has actually beaten even human radiologists and opticians in trying to get a better, more accurate labeling of these kinds of scans, right? And it's not just in these kinds of technology space, right? AI is now beginning to pervade in other aspects of life as well, right? So it's being used in making lending decisions, right? And also in various cases in the US, various states in the US, it's been started being used in judicial decision making as well. This is bail decisions. So I'll come back to this later, right? So, but just keep in mind that AI is really everywhere, right? So let's go back to ask this question. So is AI really the menace? So of course we have heard things like Elon Musk saying that AI could doom human civilization. Mark Zuckerberg disagrees. Now who is right? So both of these guys are now out of favor with the public, right? But Zuckerberg is known to be wrong more often than Musk. So do we believe either of them, right? Let's not believe them. So let's look at this, right? So there was a survey that was created of 15 Nobel laureates. They ranked climate change, right? Population rise, nuclear war, disease, selfishness, ignorance, terrorism, fundamentalism, and even Donald Trump has bigger threats to humanity than AI. Obviously, the survey was done before COVID, but still, you can see where people who should be knowing what they're talking about think AI lies as far as threats to humanity is concerned. And what about AI being a job killer, right? Everyone says that AI is going to take over all jobs, right? You can see that that's a robot that is learning to flip hamburgers. It might be a little longer before they can flip something as floppy as a dosa, but still you have to think about it, right? So here are some headlines, right? Robots are taking over, but robots are really, I mean, they're going to create more jobs than they eliminate, and AI is creating new and unconventional career paths and so on and so forth, right? So the bottom line is the following: AI is a disruptive technology, right? It's a piece of software, right? But it drives a whole new direction in which people are moving, right? So whenever a disruptive technology comes on, right, comes on the scene, there is going to be a change in the way jobs are distributed, whether it was the steam engine or industrial revolution, so whatever happened, right? So that's going to be a significant disruption. it's good, right? Because it's moving the society forward, and there will be temporary pain, and we have to make sure that we identify those pain areas very quickly and make sure that we reskill people. But it's not that AI is just going to eliminate all human jobs, right? Only, as you can see before my end of the talk, AI is not yet ready to replace all humans. There are a few things where AI can do better than humans, but they're certainly not going to replace humans anytime soon. Not in the next few decades. Right? So just to get those two things out of the way, AI is really not a menace, and AI is really not after your job. Right? Now let's get back to the theme of the talk. Right? AI is not new. AI has been around for a while. Right? So it started off with Alan Turing saying in 1950 that he's considering the question, can machine think? Right? So what does it really mean? So that led to a group of people, right, led by John McCarthy and Marvin Minsky and Claude Shannon, so on and so forth, right? A group of 10 people to get together in a kind of a conference, right, called the Dartmouth Summer Research Project, where they actually coined the word AI, artificial intelligence, and then they decided to proceed on the basis of the conjecture that every aspect of learning or any other feature of intelligence can in principle be so precisely described that a machine can be made to simulate it. Right? This is kind of the birth of AI, right? But I want to iterate a point here. It is made to simulate it. They're not making the machine intelligent, right? They're just asking the machine to simulate the process of intelligence, right? It's essentially imitating the intelligence, right? So in some sense, even very beginning, the field of AI said replicating human behavior is going to be the hallmark of intelligence. I'm not going to really look at how the replication is done. It's only the behavioral aspect of it. That's the hallmark of intelligence. That's where the field itself started, right? Now, I want you to keep this in mind, right? Whenever people start talking about AI, it's really not an intelligent machine that you're seeing. It's just that something that appears to be intelligent on the outside. So when you start attributing motivations, when you start attributing consciousness to these machines, then there is no scientific basis for that. But I want to put out a caveat right at the beginning. So what I'm talking about is a somewhat simplified view of AI, right? It's like saying that integration is just a summation of a lot of numbers, which in itself is not wrong, right? But then that kind of hides all the things that gave you nightmare in school and colleges, right? All the computation that you had to do to make sure if you did something non-trivial with that, right? So likewise, I'm giving you a much more simplified description of what AI is, right? But it's not wrong. It's just that there's a lot more to AI. Don't walk away with the feeling that, oh, AI is so simple. There's a lot more than that. Just as AI is not new, AI hype is also not new. So here's a quote, right? Here's a newspaper snippet. The Navy revealed the embryo of an electronic computer today. It expects to be able to walk, talk, see, write, reproduce itself, and be conscious of its existence. Wow. Okay, that'll be great. That's what all nightmares are made of. But this is an article from 1958. It's not something that came out in the recent hype cycle, right? AI hype is not new. So why is AI being hyped so much? Because AI success is also not new, right? So there have been success stories. This is Arthur Samuel, who wrote a checker playing program that could play a very good checker game, right? It was competitive with humans, right? And this was back in 1952, even before the Dartmouth conference, right? And so he even had a TV show, right, where he demonstrated this checker playing program back in the 50s. So that is when people say, oh, wow, okay, so this is something that computers can do. And then the expectations became very high, right? And of course, chess and AI, when we have, from the 50s, people have been trying to get better and better chess players. And so we have heard of, at least some of this in the audience are old enough would have heard of Deep Blue, right, which beat Garry Kasparov back in 97, right? And Kasparov kind of added fuel to the AI fire by saying that I could feel human level intelligence across the room. And he did predict in a few years, even a single victory in the long series of games would be a triumph of human genius. And it's the current state of the art, right? So computers have become very good at playing chess. And this again made people think, okay, computers can do a whole bunch of other things well, right? And of course, more recently, a few years back, we had IBM's Watson engine, which played the quiz show called Jeopardy. right? And which is a very general knowledge question, So, it's not a very limited domain like in chess. So people thought that this was a much more significant problem that AI had solved. And so Ken Jennings is actually considered like the champion of champions. Right? He was won against many other Jeopardy winners, and he lost comprehensively to the IBM Watson. We'll come back to how this was done later, right? And then there was this more recent story where a computer program called AlphaGo became the first computer program to defeat a professional human Go player, right? And to defeat a Go world champion, and is currently the strongest Go player in the history of the game of Go, right? And this Lee Sedol is the champion that it beat, and Lee Sedol, even though he lost the match 4-1 to date, is the only human player who has won a game against AlphaGo in match play, in tournament play, right? That one game that Lee Sedol won is the only game that somebody has won against the AlphaGo player. So which is like amazing if you think about it, because Go for a long time was considered one of the hardest challenges for AI to solve. Right? So a lot of success stories of AI, but what exactly is AI, right? So I'm going to kind of put out this hypothesis, right? So that intelligence consists of the following four components. Right? So that is perception. So the ability to perceive the world, see the world, hear the world, right? I mean, hear what people are telling, and so to communicate with the world, right? The second thing is cognition. So cognition is understanding what you see, right, or what you hear. Right? And the third component of intelligence, I would say, is reasoning and decision making. So trying to you know plan to achieve certain goals, right? Trying to use logic to reason out why something has to be done in a certain fashion, right? And then not just plan for yourself, but to be able to plan for somebody else and make recommendations and so on and so forth. So this is basically all the things that come under reasoning and decision making. And finally, learning and adaptation. So intelligence is just from examples, right? So somebody teaches you how to do things rather than you coming with the prior knowledge of how to do reasoning and decision making. Right? And you basically adapt as you see more and more examples. So these examples are what people call data. Whenever people say data is the new oil for AI, right? These examples on which you do your learning is what people call as data, right? So normally, people associate the last two with intelligence, reasoning, decision making, and learning and adaptation. Right? These are the things that people normally associate with intelligence. But a large number of success stories of AI actually come from the perception and perhaps from the cognition side of things. And without the perception and the cognition part, you cannot have reasoning, decision making, and learning. That would affect the world. Right? So therefore, all of these together are necessary components of intelligence. And as you can see, that these are really varying dimensions of trying to understand the world and affect the world, right? And hence AI ends up not being a single technology. Whenever somebody says I'm using AI, right, it's not entirely clear what aspect of AI they are talking about, right? AI is not a single technology. So let's look at it, right? So under perception, so you have things like computer vision, so which allows you to identify objects in pictures and videos and so on and so forth. It could be faces of people, it could be animals in the pictures or tumors, all the examples that we saw in the beginning, right? There are many examples that we saw in the beginning, which had to do with computer vision, right? So that is one of the technologies under perception, right? And then the second is speech processing. So things like identifying speakers, identifying words that are being spoken, or identifying music, so I mean, one of the popular things that people do in India is like looking at raga of the music, or looking at separating instruments from voice and so on and so forth. And the third class of technologies that come under perception is natural language processing, right? So where you try to identify phrases, identify the syntax, identify entities that are being spoken about, and so on and so forth. Right? So there are many, and each of these, I mean, depending on who you talk to, right? You talk to somebody in the natural processing domain, they'll tell you that there are much more finer brains of sub technologies under natural language processing, right? Like natural language understanding, there is language generation, there is dialogue systems, and etc. Right? So AI is not a single technology. When somebody says I'm doing AI, and if they stop at that, then they are not really telling you what they're doing. In fact, just an aside, so sometime back, there was a study that's done in the European Union, and they discovered that 40% of the startups that claim to be using AI-enabled technology were not using any AI at all. Okay. So these are things that you have to take with a huge pinch of salt. Right? And all these technologies related to perception have been the real great success stories of machine learning, right? And then you have similarly a parallel set of things that you do when you come to cognition. So you have things like scene understanding, right, where you have to like describe a picture or a face. You have to say things like, "Oh, there is a bottle on a table and a man trying to grab the bottle," or something like that. So you have to have a narration that describes what is there in the picture. Oh, that is incredibly hard. Right? So you think it's easy for you, right? For humans find these things easy, but it's very hard for a computer to do that, right? Same with speech understanding, right? So recognize pauses, recognize mannerisms, accents, right, and recognize the the hidden content that is there, not just the signal, right, but also the non-signaled communications. All of these things again are challenging, right? And same thing with natural language understanding. So, like I said, I mean, recognizing phrases and entities is a little straightforward, but recognizing idioms and things like sentiments or holding a free-ranging conversation and so on and so forth, these are more challenging tasks. Right? So, this I would call. I'm just giving you examples of what would be perception and what would be cognition. It's not exhaustive list, right? Just keep that in mind. Right? And AI is still trying to tackle these. I mean, there is significant success stories are there, but nothing like what you saw in perception. We don't have unqualified successes like we have in perception, and a lot of it is still work in progress. It's coming to reasoning and decision making. Right? A lot of work in this space. There are like theories of logic, decision theory, game theory, planning, and still there is no clear winner except in some games, right? And then, like I said earlier, in popular imagination, this and learning are considered the true hallmarks of intelligence, and so we are still getting there, right? So let's look at one way, right? Let's see how we play chess. Right? So when you play chess, you basically enumerate one of the ways of doing chess. Playing chess is to do something called search. So what do you do in search, right? So you take a board position, you basically enumerate all the moves and possible outcomes, right? And then you decide on which move that you're going to take, and then you go further deeper into that portion of the game, and then look at, okay, what could be my opponent's response, and then how could I respond to that, and so on and so forth. Right? So now you can, as you can imagine, quickly this can become very large, right? This can become very complex. So this very fuzzy diagram is essentially a lot of these branches going out, right? Can become large very soon, and so you need really clever ways of searching through these outcomes so that you are playing the right move and you're also doing it with a reasonable amount of time, right? So there are many techniques for conducting research, and AI has, there's a significant portion of AI that has developed that's tried to do this kind of search-based outcomes, right? And this is how Deep Blue plays. So you can see the size of Deep Blue. The cunning Deep Blue is the caption there. But then it required a lot of compute in order to do this, do a very exhaustive search so that it could play better than Kasparov. And of course, humans do not quite solve the problem like this, right? So we don't really enumerate everything and do a very deep search. But that's, like I said, the hallmark of AI now is being able to emulate human intelligence, right? So it was able to play chess really well. Right? And this is also how Watson operated primarily, not quite there. I'm hiding a few things, but there was primarily a search mechanism for looking for answers, right? So it used a more of a probabilistic search mechanism than Deep Blue did, but it's still primarily search, right? So these were techniques that could be used not just in game playing, but it can go beyond that. So let's look at an example of proving theorems, right? So how do you prove theorems? The systematic way of proving theorems would be to start with known facts, right? And you want to achieve a certain new relation that you want to prove between entities. So you repeatedly apply some kind of rules of inference. If A is true, B is true, then C would be true, and so on. Right? So then repeatedly apply the rules of inference, right? So in one way of thinking about it is start with known facts as your initial board position, right? And repeatedly apply the rules of inference is like doing the rules of the game. and then finally your endpoint is if you have managed to establish the relationship that you want, then you can say that you have a valid code. Okay, and again, grossly simplifying it, this is not trivial, as simple as I explained it to be. Right? There are a lot more constraints that you have to take care of, but fundamentally, right, fundamentally, that is a search process that happens in the whole thing, and that allows you to solve even complex problems like proving theorems. And a lot of early success stories of AI, right, were relied on search as a primary mechanism for solving problems. And so, like I said, this is search is just one technique, right? So we have logic, we have decision theory, we have game theory, we have rules, right? And we have a whole side of AI called planning, which I'm not getting into. But there are many things that people have looked at for reasoning and decision making. But this brings us to learning, right? Which, in some sense, has been the new story, right? And it's an old story as well as the new story. All the recent successes that you see of AI and many of the things that I put out in the very beginning of my talk, right, all have to do with learning. Right? So let's see what is happening. So what is this thing called machine learning now? So this is a significant component of AI, right? And the idea here is that I'm going to learn functions from input to the output just from examples. Right? So what do I mean by that? So I'm going to give you a set of examples like this, right? So I'm going to look at the first row. There's so many images there, right? And I'm going to say that each one of those images corresponds to an airplane. Right? And then the second row says each one of these images corresponds to an automobile, and so on and so forth. Right? Now your goal is to learn just by using these examples, right? Do some kind of processing on these examples so that when I give you a new image, you should be able to tell me whether it is an airplane or an automobile or a bird or whatever. Right? So how does this happen? So you basically, you learn to, recognize certain features in the input, right? It could be, you could start off with learning to look at, lines in the input or changes in color and the corners and edges and so on and so forth. And then start looking at texture. So on the left-hand side, what you see are representations. Let me see if I can turn on the laser pointer. Yeah. So what you see here are how the internally it is being represented, and here are things that it corresponds to, right? And then finally, you start putting together object parts. In this case, remember we are trying to detect objects, right? Whether it is a bird or a car or something. So you can see that now it is decided that these are all dog faces and these are all bird legs and so on and so forth. And finally, you basically learn to recognize full pictures, right? Learn to recognize dogs, etc., etc. Now, this looks simple, but it's not possible for you to do this kind of learning about 15 years back, right? And so now we have techniques that do that, right? And one of the things that drove this development is a competition called ImageNet, right? So the data example I showed you from is from ImageNet. So there were 1,000 categories, right? Like airplane, automobile, so on and so forth. There are 1,000 categories with several examples from each of those categories. And then your goal was to learn to solve this. So learn to predict for unseen images, right? So this competition has been running for a while, and you can see that in 2010, we had about close to 28% performance. And in 2011, it became like 25, so maybe like a 3% decrease in performance. And in 2012, a new technology called deep learning came on field, right? It's not new, but it was reinvented, right? So it's something called neural networks, artificial neural networks that have been around for a while, was reinvented as deep learning. Then 2012, you could see a sudden dip, right? From 26%, it came down to 16%. And you can see that the previous years there were like 2 or 3% improvement. Suddenly you find a 10% drop in the error rate, right? So the lower here, the better, right? It's the error rate that we're talking about. So and then people started pushing this deep learning frontier, and soon you found that right in 2015 we had come to a point which is this ResNet, which had dropped the error rate below the human error rate. Right? The human error rate was 5%. So that means that when you ask humans to do the same problem, right? Give them an image and ask them to tell you whether it is a cat or a dog or a deer or an airplane and so on and so forth, they are likely to make 5% error, right? So if they show them 100 images, on an average, they will get 95 right. And so the AI engine now beat the human error rate, and people said, wow, from computer vision, which is recognizing these kinds of objects, being one of the toughest problems for a computer to do, right? So imagine, right? So humans had a 5% error rate, computers have a 25% error rate. From that point, in a short period of 5 years, we have come to a stage where computers can do this better than humans. Right? So people said, wow, AI can get superhuman performance. And that started this new round of hype, and that's not there, right? It's just not in the ImageNet competition. So the speech recognition accuracy again around the same time, right, 2015 or so, has reached a point where it is better than human accuracy. The humans can get about 95% recognition rate, but machines now are actually better than humans in terms of recognizing speech, right? And it didn't just stop with these kind of interface, because all of us talk to Alexa now, and you're not surprised that Alexa recognizes what you say, or Google, right? When you talk to your OK Google and then you ask for search queries, and you're not surprised that Google recognizes what you're saying, right? In fact, I was surprised the first time Google did this in Tamil for me, right? So I was trying to use this keyboard, and then I was speaking to it in Tamil, and it actually got it right the first time, including colloquial Tamil. It's like amazing. Anyway, getting back, it's just not there. It could even do things like artistic applications. So you give it a doodle, right, and it produces like an impressionist painting, right? So it was trained on a lot of Monet paintings, and then you give it a doodle, it produces a Monet, right? Or you give it a coloring scheme and an image, it recolors the image in that scheme that you gave, right? Or getting very realistic photo recolorings from black and white images to color images. I mean, these are things that people would have considered creative, right? So now, just by using those learning from example idea, right, people are able to push the boundary to get to here, right? And let's go back to look at the AlphaGo part, right? Did it learn from examples? Yes, it learned a little bit from examples, but it also pushed the boundary more, right? It learned by playing against itself, right? So, and AlphaZero, which is the next generation AlphaGo player, which actually beat AlphaGo 100-0 in a game thing, actually did not use any human data at all. AlphaGo used some amount of human gameplay, right? So there was some amount of supervision there. But AlphaZero just played against itself, right? And it managed to beat not just, I mean, they're not even testing it against humans anymore, right? They just tested it against the earlier version of AlphaGo, and it managed to beat that 100-0, right? And also beat Stockfish at chess, which is one of those engines which are very hard. Humans also find it very hard to beat Stockfish, and it really wiped the floor with Stockfish. You can read Vishwanathan Anand's quote if you can. Right? Like, I mean, I can't read it. Let me have to come close. To watch such a strong program like Stockfish, against whom most top players would be happy to win even one game out of 100, it being completely taken apart, is certainly definitive, right? So Vishwanathan Anand was surprised that it did so well against Stockfish. And so it's a small anecdote. Even going back to AlphaGo, because a lot of AlphaGo training was done by playing against itself. It reduced a small amount of human knowledge, right? So I want to highlight a few facts, right? So that's a very strange move, said one commentator. This is move 37 in the second game, right? And I thought it was a mistake, said the other, right? Lee Sedol, after leaving the match room, took nearly 15 minutes to formulate a response, right? Because everybody said, oh, that's crazy, because it's played a move which no human could explain. And it turned out to be a crucial move that actually facilitated the win. Right? So it was amazing, right? So, and in fact, one commentator actually said later that he felt that he was watching an alien intelligence at play, right? So from having human level intelligence at chess, now we have gone to alien intelligence in AlphaGo. That's because it was learning to play against itself, right? And of course, there is this other challenging things like StarCraft, which is a much more challenging game than AlphaGo in some sense that the strategy is a lot more varied. Right now, we have DeepMind's StarCraft engine is better than 99.8% of all human players. Right? That's because it's able to bootstrap from human knowledge and improve that through self-play. Right? So the current thinking in AI is that all you need to succeed is large volumes of examples, right? Data, right? Large volumes of examples. preferably tagged examples, right? So that you know what is the right output. Okay? And for some problems like this Go and other challenging things where you only need a simulation model, so you don't even need example, right? So they can learn through self-play. And much investment in many successful products, building successful products, actually goes into generating the data. And that is why you're hearing all these new phrases like data is the new oil, data is the new water. And as long as you have data, you have your AI system in place, right? And it is challenging, right? So in fact, a lot of times when small companies, right, or MSMEs ask us, hey, look, we have no way of generating the volumes of data these AI people say that we need, right? So does it mean that we can't use AI at all? Right? No, that's not the case. And so there are many ways in which you can reuse data from other situations, or you can train an AI on data generated for something else, right? Or somebody else trains the AI in system and puts it out, right? And then you can adopt it, right? And you can modify it slightly so that with small amounts of new data, you're able to make the AI work for your situation, right? And there are many examples where people have used AI successfully, even when they don't have large scale data, right? And I mean, if people are interested, I can talk about it in the question and answer session, but I want to talk about something else, right? So, uh, like learning from these large amount of examples, right? This is not really how we learn, right? So we have teachers, so we don't really learn from examples. Right? So there's something missing here, right? And this thing that is missing causes some problems. Right? What kind of problems are we talking about here? Right? So all this database learning, all this AI stuff is good. It's fine when the going is good, right? So for example, here is a AI that is captioning images. I have to confess that these are slightly dated, right? Now you have AI that has been trained on a lot more data that can do slightly better than what I'm talking about, but the fundamental problems still exist, right? So you can see that it describes things really well, right? A person riding a motorcycle on a dirt road, or a group of young people playing a game of frisbee, or two hockey players are fighting over the park, and so on and so forth, right? But then sometimes it just goes wrong, right? Look at that. That's a cyclist who is doing some trick cycling, and then it says a skateboarder does a trick on a ramp. Okay, and then you have a little girl in a pink hat who is blowing bubbles. Okay, she's not blowing bubbles. She's wearing something pink, but that's certainly not a hat. And maybe she's a girl, right? Maybe that's a girl. So now when something like that happens, you really want to know, hey, why did he do that? Right? As long as the AI is doing fine, a person riding a motorcycle on a dirt road, you're good. Then you say skateboarder does a trick. Then you say, why did he do that? And now this why did he do that becomes crucial in many applications. Remember, I was telling you about bail decisions and lending decisions. I really need to know why did he do that. Right? Somebody, if I say that I'm not going to give you bail, you need to tell the person why you are not giving them bail. Or if you say that I'm not giving you a loan, or I'm giving you only 50% of the money you asked for, you need to tell them why. Right? So it becomes critical in such situations. So people have been working on this a lot, right? Explanations in AI is a huge area of research. And in some sense, it is the next big problem that you have to solve before AI becomes truly deployable. And there are attempts like this. You can see this picture. Just give me a sec. Right? There's an image there, right? And the AI comes back and says there's a dog and a cat in the image, right? And you ask it, hey, okay, why is there a dog? And it highlights that part of the image. That seems to be fine. Then you ask it, why is there a cat? And it highlights this part of the image mostly, right? And you're going, okay, maybe the tail looks like a cat, but it's not even catching the tail, right? It's only looking at the hind leg. Right? Why did that say it is a cat? Right? Not really obvious, even though now I say that's an explanation. It's not. You're more confused by the explanation than not, right? Now, this again is critical in other area domain, which is healthcare, right? So here is a hypothetical conversation between an AI and a user, right? So here we have deep networks have really found a lot of success here, but let's say this, right? So the AI says this person has diabetic retinopathy, and then you ask it why, and then the AI comes back and says the region looks exactly like the ones I saw, only in people with diabetic retinopathy. And then doctor says, no, but that's just normal age-related issues. It is not diabetic retinopathy. Okay. The AI could come back and say, hey, you did not show that to me earlier. It was not there in my training data, right? It's your fault. Okay. Well, AI is still not advanced to a point where it can say that, right? It basically can tell you that, yeah, these were all the regions which I thought indicated diabetic retinopathy, right? But you have to still wonder if it was your fault, because as an AI designer, did not train it properly, did not give it the right data. But how much data can you give it, right? So it's always a challenging question. Right? So how robust? So now that you've seen that this can be a little problematic, so how robust is AI in general, right? The explanations are bad, but is that the only problem? Right? So here is a school bus, right? All of us agree on that. And here is another picture, right? I've taken the school bus, added some noise to it, right? And now there's a new image. What is it? Right? Obviously, it's an ostrich. Right? Well, that's what the AI thinks. And that's not just one off. You can carefully construct this kind of perturbation that you make to the image. So look at the top row, right? That's a panda. I've added a little bit of noise. For the humans, it just looks like a panda still, right? But the AI now thinks it's a gibbon, right? It's like an arms race, right? This is just an example that I've picked. You can always go and build an AI that counters this particular example, but then I can always design another counter example. It's like an arms race. There is some fundamental fragility in the whole process that really stops us from, giving you 100% guarantees. Likewise, again, apart from the school bus, you can take the dog's picture and add some noise and make it into ostrich as well. Right? So errors are not always, due to this kind of adversarial noise, right? It's not because somebody is attacking your system, right? Errors can be because you had a truly rare sample, like in the case of the diabetic retinopathy. Maybe you didn't see it in the training, or in the case here, right? The data has an unidentified sample bias, right? So there are not enough, black people in the training data that was given to this system, and so it did great job with all the other people, but when it came to looking at some black faces, it labeled that as gorillas, right? Created a huge noise back then, and obviously this is something that is completely unacceptable for an AI system to do, right? So that was not just one off. The more people are starting to get into commercial domains, the more that you are seeing the fragility of AI. So some of you might have heard about GPT-3, which was in the news very recently, something that generates very natural sounding language, but it turns out that it's significantly biased, right? It reflects a societal bias in gender, race, and religion, right? So if you talk about, if you say something about a terrorist, it makes it more likely to be Islamic, right? And if you talk about somebody who is in the drug trade or something like that, the GPT-3 is more likely to generate text corresponding to blacks or Latinos, and so there are a lot of biases that are perpetuated by GPT-3, right? And you can come back and say, hey, that's because humans are biased, right? Humans being biased is one thing, because biases are changing from person to person, right? And it's not like one person bias is really going to become systemic. But when you start putting it into a machine, right? People have this inherent tendency to think that a machine is something that is more correct, right? It's free of biases because it has no emotions and things like that, and that the machine is going to be bias free. And it's very easy for these kinds of biases to get institutionalized. Right? So that's the subtle danger of training these kinds of systems on biased data. Right? And look at this other example. So give it a picture of Obama, make it slightly fuzzy, and this is a system that was supposed to help improve the quality of pictures, right? So not only did it make the Obama's face clearer, but it also made Obama white, right? And so we also hear the stories about facial recognition leading the police to arrest the wrong man, and in fact the police took more than 30 hours to realize that their system, or to accept that their system had made a mistake and release the man. And this man was arrested in front of his house. It was not even in a compromising situation or anything. Right? So these are things that really let you, lead you to question hey, how do we do this, right? So here is the fundamental problem, right? This is the fragility I was talking about. It AI systems right now, right? All these machine learning systems learn associations from data, right? So they have really no knowledge about the underlying structure of the world, right? So we talk about, I mean, as soon as you look at wheels, you don't think it's an ostrich, but the AI system does not even recognize wheels in the name, right? It just thinks, it just says it's an ostrich. It looks at the bus and says it's an ostrich. Right? It has no knowledge of the structure of the world, nor of the processes of the world, right? The doctor will be able to tell you why some artifact is the reason for the diagnosis, not just because somebody else who walked in before you had that artifact in the image, right? So it can tell you, oh, okay, this particular thing means that there is a blood leak here, etc., and therefore I believe that you have this disease. Right? So that is a lot more reassuring for us, right? And similarly, an AI system doesn't have any information about the societal inequities, right, and how to adjust for these biases and so on and so forth. And people are working on it, but it's still a long way off before we can. Uh, so this is why I always feel in fact I literally cringe when people when write about this new startup that uses AI to decide whether somebody should be interviewed or whether they are fit for a particular job position, or look at somebody's face and decide on their characteristics and so on and so forth. Right? When I hear stories like that, I really worried. Right? I worry. The main reason is this kind of wrong use of AI, right, can kill AI again, right? So it's we have seen this hype come up and go multiple times. So this is like the third or fourth summer for AI, right? I don't want to go back into another winter of AI because of this kind of irresponsible use of AI. Right? So how do you fix ML? So we have to integrate more classical AI. We just can't just do this association with data, right? So if you remember, we talked about logic, reasoning, search, and all those as AI technologies that were developed earlier. In fact, if you look at Deep Blue, did not use any learning, right? Or Samuel Checker's program did use learning. Deep Blue did not use any learning. Watson had very minimal learning components to it, right? So you should be able to integrate these kinds of logic and reasoning along with this powerful machine learning tools that we have, right? And we really have to go beyond that, right? So understand causality in the world and understand process models, and so therefore making the AI more robust. So I had a few slides on AI in India. So how am I doing on time? I guess I have another 10 minutes to go. Any of the organizers want to?
Sure, Professor. That should be fine. Sure, Professor. Yeah.
Okay, great. So let me just talk very briefly about this then, and then maybe we can run a little overtime for questions. Right? So AI, I mean, so India is one of the first countries to come out of the AI policy, right? So that's great, and so they talked about a lot of different things in the national strategy for AI, and but then we took about a couple of years or slightly more before we launched the national AI mission, which was launched late last, and we're still to get our act completely together, but at least there is a good push, right, from the government in order to look at these technologies more strongly, right? And a lot of opportunities in India. So India is expected to have about 1.5 lakh job openings. It says data science, but primarily what they mean here is machine learning, right? So this is about 1.5 lakh jobs in India. Well, that was before COVID, right? So what about post-COVID? Is it still the same, right? There was this survey that was conducted a month or so back, and where it said, well, in March, people expected about 1 lakh jobs, 1,13,000 jobs in AI and data science. And now, the June, the expectation has come down to about 80,000 jobs. And the majority of people are still hopeful that you'll get a good number of jobs within 3 months, right? I don't know. Now it's August, it's September, right? So we still have to reevaluate this. But I, for one, feel that COVID and all this increasing work from home and online ordering and other things that people are doing, right, is actually going to increase the demand for people who can do proper machine learning and data science and AI, and not really curtail the data science jobs. Right? So people just have to get around to figuring out the right applications. So there are many industry labs here. I mean, there were a few there, but one of the things that I would really like to see is some of this AI-based startups that are coming up. So India has, I think, the third most number of startups are based on AI in the world. But I really would like to see some of them grow to be unicorns. Right now, none of the big unicorns in India are really heavily based on AI yet. Right? And for this to happen, we really need larger investment from the government, and I think a more forgiving environment for startups, which we don't have right now. Right, we are about at $100 million US venture funding for startups, compared to several billions in China. Right, but then India is envisaging a $50 billion US AI funding in the next 15 years. So let's hope that that comes through, and we really are able to push the AI ecosystem much farther, right? So that is the industry side of things. What about academic institutions? So academic institutions are building a lot of really coordinated research centers. So IIT Madras was one of the early movers. So we have the Robert Burt Center for Data Science and AI. I'll maybe have a couple of slides on it if time permits later. And now everybody else has a big AI center. In fact, IIT Delhi is now starting a school of AI, and IIT Bombay is also starting an interdisciplinary research center, quite like the Burt Center in IIT Madras, right? And IIT KGP, IIT Hyderabad. All of these have large AI centers, primarily driven by the computer science departments, and some have large interdisciplinary departments as well. And IIT Hyderabad and IISc also have AI and related areas as separate departments. Right? And here are some studies that we did locally. So just to show you that Indians are very prolific in AI. This is some of the top 10 conferences in AI in the world, right? And they can see that the number of papers that Indians publish there is not a small number. It's a significant presence of Indians there. And you can see that about 500 of these authorships, right? I mean, so it's not 500 papers, there are 500 Indian authors on various papers come from India. But the rest of these things that you see here were actually educated in India, but now they're living elsewhere, right? So we keep talking about how brain drain is not really a thing anymore, but it is really still very much a thing. And don't blame just IIT. Right? Many of these people who are publishing from elsewhere are non-IITians as well, many, right? And I just wanted to call this out. In fact, when I did this in a talk sometime earlier, somebody asked, so what? And I'm actually appalled just by the question. So the gender imbalance in AI, right, globally is about 22% women, and in India it's 12%. Right? And so I think even though AI is a discipline which is kind of a lot of computer science people do enter into it, right? It's largely viewed as a CS discipline, even though that's not really the case. And so in India, the gender imbalance is not this bad in computer science. But for some reason in AI, we see this, and I would really would like to see more women also get into this. And one of the main reasons is if you look at many AI systems that people build, they have a significant gender bias, right? So many AI systems tend to do well on, for example, on men faces, right? On male faces than on female faces, right? And likewise for language generation, we are more happy generating language with men in it rather than women protagonists. So all these kinds of inherent gender bias that are there in these AI systems will also kind of go away if we have more women and other people in the research agendas. Right? And a lot of degree programs that are offered now, this very focused on AI. And again, at IIT Madras, we have a dual degree program in data science, and we also have a new online data science degree program. Right? And so we have BTechs and MTechs in AI offered at many institutes, IICs, IIT Delhi, IISER Bhopal, IISER Pune, and so on and so forth. Even IIT Bombay is now offering one. And a lot of AI training programs. In fact, it's very quick. It's replacing all the IT training programs that you were having. It's becoming one of the larger market shares now. Right? And IIT Madras has launched this 3-year online BSc degree in programming and data science. A large number of electives and courses that you learn in the second and third year are all geared towards machine learning and AI. Right? You can look up the web page online degree.iitmadras.iitm.ac.in, and there are multiple entry paths. I mean, you could come right after your school, right? But you could also have an entry for a diploma if you're a working professional and so on. So please look at the page for more details on this. So that's the page, onlinedegree.iit. And so the way forward for AI has been undoubtedly successful in some specific domains, right? But the current AI systems understanding of the world is about that of a 2-year-old, right? And really, even 2-year-old is being a little generous. It's a long way to human-like performance, right? But we have to handle it with care. We have to make sure that we are being responsible in the use of AI, because AI is more like this kid, right, than any other 2-year-old, right? So it can have potential for great destruction. So summing up whatever I have been saying, we are closer than ever to functional AI, right? Again, so we thought we were close to functional AI even in the 50s, again in the 80s, again in the 90s. So again, we think we are close to functional AI. Importantly, it already affects many aspects of everyday life, right? And so much so that we find that lawyers and lawmakers are getting into it. So people all over the world, politicians are talking about making laws and things like that. And for me, the biggest danger from AI is not the AI itself, but it's humans who are going to rush to market before the technology is ready. And just as you would do with any technology that is not ready, right? If you put out a faulty car design, you're going to cause a lot of accidents, right? So like that. So we really need discussions on regulation for AI. And so we really need to ask the question, was it really your fault or whose fault it was? Right? So all of these are there. Right. And if people want to know more about, read up on AI, right? So the Russell and Norvig book is like the Bible on AI, right? But the Melanie Mitchell's book, A Guide to Thinking Humans, or Master Algorithm, so all these are more accessible, written for a more general audience. Right? I encourage people to look those up. And since we're really out of time, I'm not going to talk much about my center, just point you to our center and a lot of good work that we do there. And so we are on social media, all kinds of social media. You can actually find us there or go to our webpage and take a look. So thank you. I'm ready to take questions now, if there are any. Maybe I should exit my shared screen to look at the question answer panel.
Thank you, Professor. Or if you allow, should I read some questions to you?
Oh, if you can read, yeah, that'll be great. Yeah.
So we have quite a few questions. So Dr. Shiva Raman is asking how AI can be used in MSME sectors for its manufacturing activity.
For what activity? Sorry.
For manufacturing activity.
Oh, manufacturing activity. Okay, so it's a challenge, right? So because one of the things is many of the AI solutions that are out there are places where there is large data, right? And so with MSMEs, we have to identify what are the right use cases. For example, logistics. A lot of work has been done in AI-enabled logistics solutions that would certainly help MSMEs. And so even I have worked with some companies which have been building solutions like visual inspection solutions for smaller scale manufacturing systems, right? And more recently, Bosch has come out with a solution for it's a whole platform for MSME sector, right? This is AI-enabled solutions for MSME sectors on various aspects of it. And I don't know if there is a single silver bullet answer to this question. It's not like there is a, like with you have with like human face recognition and object detection, those kinds of things. There's no packaged solution, and so we really have to have a conversation and figure out how this is going to work. And at our center, we do work with a few smaller companies in order to come up with robust solutions for MSMEs. I'm happy to talk to Sivaraman offline.
Sure, thank you. The next question we have from Mr. Nemai Gorai. He says, when error in AI is less than human, a human is going to commit more errors as we now believe more on AI decisions. So gradually we'll start learning from AI. So then how AI will improve further? It's interesting.
No. So see, this is the thing, right? This is what I was telling you towards the end of my talk, right? So AI, the superhuman performance of AI is in some sense illusory, right? So AI is not the superhuman performance that we're talking about is not robust. So AI has had the most success in areas where the users really want the AI to succeed, right? So my wife points out saying that when I talk to Alexa at home, right, I actually talk slower. And I'm pretty sure people who have these kind of these home assistants actually have noticed this, right? They tend to talk slower and pronounce things more carefully, so that you'll expect the AI to recognize what you say, right? So when I go to this kind of image recognition problems, and like we were seeing, right? So once you start adding some amount of noise to the images, the AI goes fantastically long. It takes a school bus and says it's an ostrich. Now, humans have a lot more deeper understanding of what is there in the scene, right? So they are not just learning from large number of examples, right? So we are not doing that, right? So we actually have a lot more abstraction of what is happening in our head, and we are able to make robust decisions, right? And that AI is still not there yet, right? And that is one part of it. And of course, humans can learn from AI. There's nothing wrong with it, right? In fact, in the case of the Go playing engine, I was telling you that Move 37 I was showing you, right? That was a move which now humans could potentially learn from the AI and learn to play that now, right? There's nothing wrong with that. So, but that doesn't mean that the AI won't learn, right? There's a lot more that the AI needs to understand about the world and the structure of the world that humans can actually give as inputs.
Sure.
There's nothing that says that AI has to learn from a human. Right? So AI can learn from other sources as well.
Sure.
Go on.
We actually have quite a few questions from students. They are seeking your advice and on one that what are the kind of courses they should be doing? Is there any kind of from where the AI research should begin? If you can just give some kind of your inputs or your tips to the students of how they should begin for their career, and what are the job opportunities? Sorry.
There are two things. There are two things. Job opportunities there everywhere. Right, I'll just tell you two things. Right. So there are people who are going to build AI solutions. They're going to build AI systems. Right. And for them, I would say that you really need to get good at programming. Right. So Python is a language of choice, and so you should learn Python, and you should learn some kind of a platform like PyTorch or TensorFlow, or one of those which allows you to do large scale software development quickly for AI, right? So that is for the first part of it. The second part of it is you need to go through some kind of whether it is a good online certification program or whether it is a proper degree program at a good institute. It's better to have training like that, right? In order to become a good AI developer or AI engineer, AI solution provider. So on the other side, you have people who are going to give use cases for AI, right? And this could be lawyers, this could be engineers from other disciplines. It could be a civil engineer, it could be a doctor, right? It could be an accountant, right? So it could be an auditor. So the use cases could come from anybody, right? But you need to have some kind of an understanding of AI, so that you can talk to the AI engineer and say, hey, this is what I'm really looking for, because AI is not magic. Right? You can't say that, oh, can you solve my problem, right? Without understanding what is it that AI can give to you, right? And then for people like that, I would recommend very introductory. There are many courses that are there online now. I can't immediately give you recommendations, but there are simple courses where you could learn about what is AI and how it's going to help you. In fact, Melanie Mitchell's book is a good starting point that I had put on my slides earlier, right? And that's a place where you can learn something about what AI is, what it does, and that will help you talk to these people. So getting back to the AI developers, right? So some people have asked me, do I need to get a master's degree in AI? Not really. Do you need a master's degree to become a software developer? No, right? So there are multiple, that's a hierarchy in AI development also. I mean, there are people who would be who would be the soft equivalent of software engineers. There will be people who would be the equivalent of architects, right? And so the people who are the equivalent of software engineers really need to go through a tool. orientation, right? They need to understand TensorFlow, they need to understand some of the data structures, they need to understand distributed file storage and things like that. So those are the kinds of things that you would really need, and you can pick it up from many of the training programs that are out there, right? And then for the people who really have to get into the architect, the solution designer level, you need to understand. I would very strongly recommend a formal program, right? It could be a master's degree, or it could be one of those bachelor's degrees in AI that are being offered in many places. In fact, the way I look at it, the colleges that offer a 4-year undergraduate AI degree are more or less, give you the similar kind of training as colleges that do a post hoc 2-year AI masters, right? Because they really bring you up to speed on the AI side of things, because in the undergraduate level, you have not learned any of these things, right? So by the time you get out of a 4-year master's degree and you do a 2-year post-graduation in AI, then you're kind of at similar level when it comes to AI solution design. There are a few programs like ours which do a 5-year integrated thing, right? So those can actually push you a little farther down the pipeline, because it's designed as a 5-year program. So it's your choice, right? And at this point, if you ask me, do I take up? Do you really want me to do a master's in AI to get into this field? It depends on what level you want to get into.
Sure. Then thank you, Professor. I think that was quite useful. I'm sure students will make the right choices. I think I'll take last 3 questions. We have already overrun the time. So
Yes,
one question from Mr. Muruga Prabhu. He's asking, can you help us in simple words the basic difference between AI and ML?
Oh my God! I thought I did that in the talk.
Yeah, I thought it was being clarified in the talk. So
Yeah, but anyway, so let me get back. Let me try to do that very quickly, right? So I said there are 4 components of intelligence, right? So what we would call as intelligent behavior. I said perception, cognition, decision making, and learning, right? So machine learning is that 4th component, and all 4 put together is AI, right? So it's nothing like, oh, this is machine learning and that is AI. Like machine learning is AI. Okay.
I think,
and there are components of AI which are not necessarily machine learning. In fact, perception can also be solved through machine learning, right? So it's not like these are all like independent technologies, right? So machine learning is whenever I'm learning typically primarily from examples, right? And the other forms of AI is not necessarily driven only from examples, but looking at models and reasoning and logic and other things.
So can we say, Professor, that ML is a subset of AI?
Yeah.
Thank you. Another question we have from Mr. Vikas Srivastava is that he says, what is your opinion on data generation that requires large capital to start with in particular? Will such areas remain untouched in absence of reliable data?
Yes. So at least in India, the government is kind of beginning to realize that if they want to give this impetus to AI, they have to do the investment in at least the data generation. Right? So there are many sectors, including things like agriculture and healthcare and education and law and order and so on and so forth, right? Where the government is starting out initiatives in terms of generating data and making them available for people in some kind of a controlled fashion for people to build products and companies around. So that hopefully that will come to fruition soon, right? And I would say then getting back to the earlier question on MSMEs, I think there should be some kind of a consortium of MSMEs that does this kind of data generation for that as well, so that you can start building solutions for that, right? And
Sure.
And we'll be happy to facilitate some of that. But I agree. I mean, there are some places where data, multiple reasons, not just it's expensive to generate, but there are ethical considerations, privacy considerations, and so on and so forth, which makes it expensive in a completely different way, not just monetary, right? But this could something that could affect the social fabric. Right? In such cases, yeah, we have to be very, very careful and worry about whether we should be generating that much data.
Sure. We have another question from Divya Shri. She says that how AI can influence blockchain.
They're completely different technologies,
Yeah.
right? And yeah, sure. I mean, you can always find, I mean, just like you would find applications of AI in manufacturing, I'm pretty sure if you dig deep, you can find applications of AI in blockchain. I'm not an expert on blockchain, right? And so one place which I feel is an uh, interesting area would be when you start looking at things like provenance, right? So I'm going to give you some data. How am I sure that the data has been generated in the fashion that I say was generated? It was generated, right? Is there a way to ensure, like the chain of possession through a blockchain, right? So to guarantee that the data is being used as it is supposed to be used, or was generated from a particular source and it's now being given to you? So those kinds of blockchains could facilitate trust in a data economy. So that's one possible way I can think of where blockchains can help AI. But the other way around, I'm not sure. I'm pretty sure there are people working on it. But just like AI is touching every technology, I'm sure it will touch blockchain.
Sure. We actually have a lot of questions still pouring in, Professor. So I think I'll request the participants to send the questions over to us over email so that we can send it to you for your help.
Yeah, if you could
Answer.
collate the questions, and then send it to me,
Sure.
I could try and take a stab at it at some point. Yeah.
Sure. One last thing which I would also be curious, and I'm sure it will help attendees also. So one of the attendees has asked that what has made you to stay back in India to do continue your AI research or work when there are bigger, better opportunities in the Western part of the world. So what really makes
Are
you
you
stay back here?
sure?
I mean,
Are
the
you
fact
sure?
that the fact that
No, no,
the
no,
very fact
no,
that
no.
you
My
just
question is,
mentioned that.
are you even sure that there are better opportunities in the West, right? So now I'm actually beginning to see a lot of companies are increasing their India operations because a lot of challenging problems for AI are coming from countries like India and China, right? So if you want to build solutions for Africa, the place that you're going to work on it is in India, right? So I would actually tell you that India is the land of opportunities for AI for the next decade and a half, right? Not the West.
Yeah. So I think with the kind of large data that both the countries generate, which is India and China, the huge
Let's
opportunities does come.
let's not talk about China, okay? China, I mean, frankly, doesn't worry about a lot of things that India worries about, right? So we cannot compete with China in in the amount of how intrusive we are in data generation.
I'm sure. I'm sure.
So and then there are problems the Chinese government solves, the Chinese companies solve, which are qualitatively different from some of the fundamental problems that we have. Right?
But
So I think a lot of solutions that Indian society faces need to be solved by Indians. Nobody else is going to do it for you, right? And there is a lot of scope now in India to grow. Right? I don't think the West has more opportunities. If I had been in the West, I'd probably be looking for a way to come to India now.
so I think
Not
I would.
happy I came back 15 years back. I didn't wait till now, but yeah.
I would agree with you on that, Professor. I think that is the reason that we see a lot of large multinationals to be investing in India with a lot of their research centers. So if we talk about Microsoft's, Google's, they all are putting up their research centers here because of the huge opportunity which lies in this country,
Yeah.
especially in area of emerging technologies. So I think with that, I will not take any more questions. I would once again request all the attendees to send the questions over to us in the email if they haven't already posted it, and we will try our best to convey those questions to Professor and get the answers for you. So with this, Professor, I think we come to an end of the webinar. So I thank everyone for joining us, and I'm sure the webinar was very informative for all of you. It was quite insightful, quite educative. It clarified a lot of my personal doubts. So my personal thanks to you once again, Professor. And once again, our
Welcome.
special thanks to Professor Ravindran for his time out of his busy schedule to talk about AI and help all of us with more clarity on the subject. And I also take this opportunity to thank Geeta Training for their kind support for organizing this webinar and introducing us to Professor Ravindran, bringing him here. So with this, I would say thank you to all of you and stay safe. Thanks.
Thank you, everyone. Yeah, stay safe. Bye.
Thanks.